Hi everyone, this is Sadish Kumar from Kogunadu College of Engineering and Technology. Now we are going to discuss about an subject soil and water conservation. In this we are going to discuss about unit 5, that is sedimentation. In the sedimentation unit we have source of sedimentation, types of sediment, mechanics of sediment transport, estimation of bed load, then sediment graph. The next topic is reservoir sedimentation, basics, factors affecting sediment distribution pattern, rates of reservoir sedimentation, silt detection tanks, sedimentation control methods. These are the topics we are going to discuss in this unit. Sedimentation is the process of settling down the heavier particles which is present in the liquid. It may be a mixture of that. Then for example, the mixture of sand and water is the best example for sedimentation. Sand settles down at the bottom of the water. This is called sedimentation. If you see in this beaker, sedimentation is happening in second beakers. In first beaker it will be mixed together. Then second beaker, if you are leaving inside some time, then it will be deposited at the bottom of the tanks. Then sources of sediments. The sediment source is divided into two categories. One is upland sediment source, then one is as channel source. Then upland sources include the various land use, land cover types, that is forest, cropland, pasture, construction sites, roads, etc. While coming to channel sedimentation, in this channel sedimentation, the water which is to be diverted from the reservoir or river, it contains some quantum of suspended particles. That suspended particles is deposited in the channels. That is called sediment source of channel sediments. Then coming to what is sediment transport mechanism, the main variable that is in transport mechanism are distribution of suspended sediment, that is concentration, erosion accumulation zones, bottom shear stress, and grain size distribution. It is difficult to obtain all these parameters from the in situ measurement, so that temporal and spatial heterogeneity is happening in that field, so that we will prefer the laboratories as better methods. Then types of sediment load. When the particles are eroded and transported by water, they become part of the transport medium sediment load. They are three categories are there. One is dissolved, suspended, bed load. So this will tells you about some of the overview of that sediment types, sediment load diagram. It has and water flow direction is there. Some particle is to be rolled, something is to be slided, something is to be saltation at the beds, something is to be suspended. So something is to be dissolved in this water too. So suspended is happening due to turbulence effect. Dissolved in terms of minerals and solution are mixed with together in this water. So that is called dissolved loads. If you are seeing this diagram, we can track how the particles will be separated at the bottom of the channel or river body. Definitely if you are putting any material in this water, then definitely it contains some uplift force. Then water will be moved through the horizontal direction. Then it will create some drag component as well as resultant component. Then we have some gravity force in our earth, so that our particles will get settled down. So that gravity force is one of the important criteria. Here the some joisting, rolling, sliding will be comes under at the surface. Then no movement at the bottom of our bed. Then if you are seeing this at top of the diagram, saltation is load is there. It will be mostly suspended in water. Then traction carpet area, carpet is comes under some of the particle which is deposited is called traction. While coming to types, dissolved load. Dissolved load is the portion of the stream total sediment load that is carried out in the solution, especially ions from the chemical weathering. Whatever the content which is to be mixed or dissolved in water is called dissolved load, which is at the surface of the water. Mostly it is happening. It is definitely most of the time it is invisible. Sometimes it will create some colors to that. Then saltation is then another load. Suspension, saltation, and bed load which are suspended in matter which is available in the soil medium. The saltation and the sliding rolling particles are the bottom of the bed, then it will be called as bed load. Then suspended, it will be mostly suspension. For suspension, clay, silt are the particles for suspended load. That bed load, sand, gravel, boulders are will be comes under bed load condition. While coming to next, bed load is mostly comes under this rocks medium which is to be carried through water medium is called bed load. These are the three types of loads which is available in our syllabus. Then next one is methods of transport sediment. Transportation of sediment is happening by traction, saltation, suspension and solution. We already discussed about different loads in our bed. It will be traction is separation of particles, then saltation is mixing of particles, then suspension is mixed particles floated, then solution is fully thoroughly mixed with together. In traction particles, separated particles, huge particles will be moved in the flooded water, while saltation particles is moved in the normal flow itself. Then suspension happening anywhere, wherever the clay particles is there, silt particle will be suspended. Solution wherever it may be, it will be transported without high views. That is called transport mechanism. Then next one is sediment graph. So this graph will show you the different turbulent flow and laminar flow, so that at that time we are receiving some quantum of discharge. Based on that we are receiving some suspension, saltation. There is no movement based on the particle diameter, like that particles are there. So that this graphs will show you the information regarding the sediment. If your particle Reynolds number will get increased, then automatically your sedimentation will get decreased. Then this graph will show you about sediment diameter versus flow velocity for different soil particles. If you are seeing in this clay, then silt, sand, based on that particle size, the transportation will be happening in some places. In most of the settling velocity also there, the erosion velocity is there. The red line will indicate you this erosion velocity, while coming to settling velocity is called denoted as an blue color line. So that orange color, green color and light blue color will show you some of the soil particles which is available in that, so that we can track when it is happening, that kind of erosion and deposition and transportation is happening. Likewise we can analyze easily through this graph. This is called sediment graph. That is sediment concentration. That sedimentation concentration current velocity is high, means this will diagram shows you the velocity versus concentration. If your velocity is less, the sediment will be more. You see the suspended load also, it will be more at the 3/4 of the height. Okay, well, likewise graph will teach us. Then reservoir sedimentation. Reservoir sedimentation is a graduated accumulation of incoming sediment load from a reservoir. Okay, why it is a river, that this accumulation is a serious problem in many parts of the world and has severe consequences for the water management, flood control and protection of energy. So it will create lot of problems, because that sedimented particles will keep on increasing the deposition, so that the particles will be keep on reducing their capacity of the reservoir, so that we cannot satisfy our demand. So that reservoir sedimentation is a huge problem, so that only every year we are desilting our water source structures, because every year we are receiving the water during the rainfall season, so that through that water definitely we are receiving most of silt particles and clay particles, and as well as bed load particles, that like gravel, sand, like are deposited in our storage structure. If you are not removing that every year or periodically, then it will create definitely some volume changes in your storage capacity, so that you cannot predict the exact value of our water availability. So that your reservoir sedimentation is very, very important criteria in nowadays. Then in this you see here, there is an n number of particles are settled down in this reservoir, so that that eroded particle will be keep on decreasing their volume of water storage in the reservoir. Then toe slope is there, bottom slope is there, then front slope is there, delta is there. Then sedimentation is happening in delta and erosion is happening in delta too. That eroded particles will be deposited in the front that is top sheet slope, then bottom slope also there. The diagram will shows at the dead end of our dam velocity is equal to 0, then V is equal to maximum at the head end of our water storage. Only a part of sediment is passed through the river sluice. The other particles, most of the other particle will be deposited in our dam itself. Smaller particles only, clay, silt particles only carried through the reservoir sluice. So because our storage structure is huge, if you are stagnating that water, definitely your particles will be deposited. Some small quantity only it will be moved through this reservoir. Then reservoir sedimentation, it is reservoir blocks the downstream transport of sediment. Then sediment accumulates in the reservoir sedimentation, that is reduced sediment supply to downstream areas, hunger water, that is downstream erosion, bed erosion is there. If you see this diagram, that black shadow will called as reservoir sedimentation. If you are keep on depositing the sediment particle, then you will not allow the particles, you will not allow the water to through the river reservoir sluice, so that it is a major problem for removing the water in this stream. The next one is factors that affecting the sedimentation process. The shape and size of the particle, density of the particle, water temperature, dissolved substances, environmental effect, characteristics of basin, slope of the stream, reservoir length, size of the sediment, inflow capacity, reservoir operation, inflow pattern of the stream, vegetative growth. Based on that factors, the sedimentation process is happening. Then next one is silt detection tanks. The tanks which are utilized for detecting the silt particles, this is adapted whenever you are constructing a dam. You must be remove that silted particles is difficult, because if your dam is keep on watering means you cannot able to remove that silt particles. So that we will construct a silt detection tank in front of our storage structure. Before entering into this dam, your water will be conveyed through this check dam like structure. Then automatically your most of the silt particle is deposited, then you will keep on removing that in this place itself. Then automatically your reservoir will get improved. So this kind of silt detection tanks will be provided. A tank also called as reservoir retention tank is an artificial flow control structure that is used to contain storm water and wastewater for the lined period of the canal. If in some places, if you have some lined canals, it will be connected with our local unlined canals or unlined streams, that is to be avoided to enter the silt particles, so that this kind of obstruction structure is constructed. This structure also utilized for discharge measuring device. If you want to identify how much quantum of water enter into your reservoir, you have to need some structure, regulated structure, just channel type structure, so that structure will be utilized for detection tank as well as silt detection tanks. Then this is about sedimentation control methods. So sediment is to be controlled through this kind of obstruction structure. If you see in this first diagram, that water particles is to be keep on moving, then it will create some sedimentation at the bottom. If you are stopping that, it will be deposited at the head end itself, then you will automatically remove that particles from the top end. So this kind of sediment control mechanism are provided. Then this is about mulching mat to avoid the erosion, so that your sedimentation will not be happening. This kind of protection is needed. The next one is about bypass channels. Bypass flumes are to be provided for regulating only water. It is like a sedimentation tanks. The next one is reservoir desilting. Using this kind of machineries, we will desilt the particles in the water medium. Through this pipeline system, we can remove this sedimented particles every year. If your dam is a perennial dam, then you have to use this kind of technologies for protecting your storage structure. Then fencings are provided for avoiding silt particles enter into your streams. So up to this, our first unit is over. Thank you.